Welcome to the video on E and Z nomenclature for alkenes. This becomes important when we have an alkene that is more complicated than a simple trans and cis nomenclature. Remember that stereoisomerism piece gets put in front of the name. Okay, this is going to be a quick video on nomenclature for alkenes. Up until now, I have told you that we can use these terms cis and trans to describe the configuration about a double bond. Cis being the two big groups are on the same side, and trans meaning the two big groups are on the opposite side. Well, it turns out that sometimes we're going to have compounds that have more than one big group off of each carbon. And so we've now modified that cis-trans to become more advanced and more exact, and that is the E and Z nomenclature associated with double bonds. And so let me show you that real quick. The reason it's perfect to introduce right now is because we had just done R and S, and we use this Kahn-Ingold Prelog system to figure out priorities in R and S determination, just as we will in E and Z. And so it makes perfect sense to add it right here. I promise this is a quick video and it's a pretty easy process. Using the CIP system, we're going to prioritize the groups on each carbon. So you'll be given a double bond, and I highlight each carbon like this, and I take one at a time. So we'll work with this carbon first. So off of this carbon, I have a fluorine and a carbon. So remember, we're talking about the atom that's attached. So directly attached to this carbon, I have a carbon and a fluorine. Fluorine has the higher atomic number, so it wins on this carbon. We go to the second carbon over here, and I will make that a different color so that we can keep track, right? So on the second carbon, we're going to look at the priority. At the top, that carbon is attached to a hydrogen, and at the bottom, it is attached to a nitrogen. So which of those two has the higher atomic number? It is nitrogen. So if I take a look at my double bond, if the two groups that are higher priority fall on the same side, then we call that Z. And a way to remember this is those two highest priority groups are on the same side. This slide shows us what the diastereomer looks like. So here is the Z, that's the one we just did. Right here's our double bond. Fluorine has the highest priority over these two groups. Nitrogen has the highest priority over these two groups. And so because these are on the same side, that is going to be the Z diastereomer. Alternatively, if we look at the E example, here's our double bond. If we look at the priorities off the first carbon, fluorine wins over carbon. And if we look at the second carbon, nitrogen wins over hydrogen. And so these two groups are on the opposite side of the double bond. So this compound with them opposite is E, and the compound with them on the same side is Z. It comes from the German word zusammen, which means same, and entgegen, which means opposite. This E and Z notation is going to go at the front of the name again. And also I want to tell you, cis and trans, we can still use those when there's only one group coming off of each carbon, but you can always use E and Z, even if there are only two groups. Okay, good luck.